They should not put those right next to each other.
All right, so let's go over this and see how you did. So your cross, get a blank sheet of paper here. So your cross looks like this. Let me get a black here. So you had, they were both homozygous, so both of the parents originally. And so what that looks like, so since we're making, we said that they were unlinked, so again, that looks like they're on two different chromosome pairs. So this parent is B plus B plus, and this parent at chromosome pair number 2 is BG plus BG. And then you're crossing it with, in this case here, the all recessive. Again, what does that mean? The B's are on chromosome pair number 1, and the BGs are on chromosome pair number 2. So when this parent here goes to make their egg and sperm cells, they're going to pass on one chromosome number 1 and one chromosome number 2 to their kids. For these two traits though, both of the chromosomes are genetically identical. So they're going to give one chromosome number 1, no matter which one they give, it's going to be with a B plus on it. And they're going to give one chromosome number 2, no matter which one they give, is going to have a BG plus. So this is what, if this is like, let's say that was the female, this would be like what her egg cells would look like. And then if this was the male, he would do the same thing, go through meiosis. You have to imagine that in your head. And he's going to give one chromosome number 1 with a B and one chromosome number 2 with a BG. And that's the sperm cell. So therefore, sperm fertilizes the egg, and you're going to have a kid that has the B plus B, BG plus BG. And so if we were to do that in a Punnett square, you could do a big Punnett square with 4 possibilities for each parent that could pass on this B plus with this BG, this B plus with this one, this B plus with this one, this B plus with this one. But they're all, as I said, identical. And the same thing with this one. You could do 4 possible combinations, B with BG, B with BG, B with BG, B with BG, but they're all B with BG. So you could, like I said, do a big Punnett square, or you can just, could be a very small Punnett square where this parent, there's only one possible combination that they could pass on to their kids, a B plus and a BG plus. And this parent, there's only one possible combination, a B and a BG. So therefore, all your kids would be heterozygous like this. And so that you could do that, or you could, like I said, do the big Punnett square and you get all 16 boxes heterozygous. Either way is fine, okay? So these are the kids for that cross. So then it's asking you for the test cross. So this is the kid, heterozygous for both of these, and the test cross is all recessive. So in this case, it's BB and whoops, BG, BG. All right, and so again, I like to draw the chromosomes just because it's going to help with the next part of this. So this parent for chromosome number 1 is heterozygous, and same thing with chromosome number 2 is heterozygous. This parent is homozygous, so therefore both chromosome pairs look identical. So again, this parent here is going to pass on one chromosome number 1 and one chromosome number 2 to their kids. So in this case here, because both this parent is heterozygous, there are lots of choices. So this is where that foiling comes into play. So they can pass on a B plus and a BG plus, a B plus and a BG, a B and a BG plus, and a B and a BG. So there's 4 combinations that this parent could pass on. How many combinations for this parent? 1. I mean, you could do 4, but all 4 of them are exactly the same. So therefore, again, you could do a big Punnett square or a smaller Punnett square. For this parent here, you're going to have 4. I'm going to put them across the top. So there's 4 possible combinations: B plus, BG plus, B plus, BG, B, BG plus, and B and BG. For this parent, you could do 4, but all 4 of them would have a B and a BG. Since they're all 4 going to be the same, I'm just going to make a 1 thing like this and make a Punnett square like this. But this parent has 4 possible combinations to pass on the kid. This parent only has 1. It results are gonna be the same. You're either gonna have a 4 to 4 to 4 to 4 ratio, or in my case, a 1 to 1 to 1. So this one here is B plus B, VG plus VG. This one is B plus B, VG, VG, B, B, VG plus VG, and lastly, all of the recessive. So when I do the phenotypic ratio, this one has both the wild types, which is dominant. So I would have one gray body, normal wings. To this one has the dominant gray body, but has vestigial wings. To one, this one's gonna have, this is recessive, so they're gonna have one black body, but it has the dominant normal wings. And to one, all recessive, which is black and vestigial. So that's my phenotypic ratio. So if you did the big Punnett squares, yours would be a 4 to 4 to 4 to 4 ratio, but you should have all 4 of these phenotypes and the possible combinations, all right? And this is the results you would expect doing a dihybrid cross with the with the heterozygous and the homozygous recessive, and you expect this 1 to 1 to 1 ratio. So you expect roughly equal amounts of each kind of kid from these flies. All right. So now what we're going to do is, if you flip it over, we're going to see how this changes and if the genes happen to be linked. So we did these guys on separate chromosomes. Linked means that they're on the same chromosome. So now our cross, if you notice on the back, our cross is still going to be the same. So we're starting out with all homozygous and all homozygous dominant here with the wild type and homozygous recessive. So our cross is the same. But in this one, I want you for sure, when you're doing the work, I want you to draw the chromosomes. I drew the chromosomes for this. I want you to do that for linked. It makes a difference. And so it'll be helpful. And so what does it mean for linked? Let's say on chromosome pair number 1, you have the B and the VG gene. We know that for this parent, the B plus and B plus are in one spot, and the VG plus would be in another spot for that. So therefore, that's what that parent looks like. They're linked on the same chromosome pair. And so then this parent is also homozygous, so their chromosome number 1 in that same spot has a B and a B and a VG and a VG. So now what I'd like you to do is do the same problem. It's the exact same problem, but now we're assuming that the genes are on the same chromosome like this, and follow that through to see if your results differ than the previous one. All right, so I'm going to give you a minute to do that.